Hello everyone, in this video we are trying to follow this book Cloud-Based Remote Sensing with Google Earth Engine Chapter A1.6 Health Applications. In brief, this chapter is about calculating and exporting data of remotely sensed environmental variables, precipitation, temperature, and vegetation water index. 4 different datasets are used. The first one is the global precipitation measurement. Second one is the Terra land surface temperature and emissivity at the global 1 kilometer. And the third one is Moody's Nadir BRDF, adjusted reflectance daily 500 meter. And the fourth is the Moody's BRDF albedo quality daily 500 meter. So this chapter mainly works with the dates and shows us the example of exporting the datasets as CSV. And this chapter is somewhat complex as everything happens with the dates, and I personally did not like the chapter that well because these things with dates make it more complex and make it more confusing. So I'll try to run through the chapter, not exactly going through each and every details, but these minor details are still helpful if we learn it and use it in our context. So there are some helpful things such as the file naming while exporting and how to use the reducers. And in overall, this video is just to know what this chapter is about. So here we begin with the very first section of the code. So here we are exporting the region. This is somewhere in the Ethiopia, and we are importing 4 different data sets, and after that we are adding this as the layer. And before adding this as the layer, we have here the empty image created, and in that empty image we are providing the color and white to the feature collection just to make the area or the region more appealing. So this is the first section. It just starts with importing the datasets and our region and adding this as the layer with some colors and whites. The main thing happens at this section 2. So here we begin with 2 different dates. So here is the request start date and the request end dates. So these are the dates that is of interest for us, and what happens is that these datasets are available at every 8 days, or some may be available at the interval of 30 minutes, or each data comes with different intervals in the time. So for that reason we want to know the dates and particular dates where the nearest images are available near to our date of interest. So here we are selecting the very first image and the date of that first image, and then we are filtering to the first image date to the date of our interest, the main start date of our interest, and then we are reducing with the e.reducer.max to get the maximum date, or the date that is very nearest to the start date that is of interest to us, and we get something like 2021-09-30. This is the date that is nearest to the request start date or our date. And similar thing has been done for the precipitation. Here we are reducing it with the e.reducer.max to get the maximum date, and from that date we are selecting the year, month and day, and then if the indents are not available, we take the last date or the requested date if the last indents are not available. So these are just to show that the works are to be done with the dates before filtering the image collection. And same thing has been done with the BRDF as well. So this e.reducer.max is helping to get the maximum date, and if the data ends before the requested start date, then the last date are to be used. But it is making some sort of confusion why we want to do this actually, and I think this is what the researchers wanted to know, the different images available with the dates. So here we are just playing with the dates and nothing more, and here the real thing begins more. So here we are filtering this precipitation data with the precipitation start date, and then we are advancing one day ahead, and this precipitation start date is something very different that we used to find before anyway, and this is again reduced to get the date of the most recent measurement, and then here we are getting the date, that is the in date, and then we are also getting this in date printed at the console, and we can see this precipitation in date is 2021 11/30, and we are creating the list of dates for the precipitation time series. So we're subtracting the precipitation start date with this in date, and then we are creating the sequence of the days, and for each day we are making this function to advance every one day ahead. And the main thing happens here, we are calculating the summation, or we are adding the images present within this to date, and we are multiplying with this constant, and then we are renaming it as something else, and we are returning it with some more properties added to it. And this is mapped over the list of dates, the dates that were just created earlier here, and then this is again filtered to the original dates with the request start date and in dates. And some preparations are being done here for the journal statics. So this daily precipitation is again filtered with our dates of interest, that is the request start dates, the request start in dates, and then inside this function here we are adding some bands, and then we are reducing it with the mean, and this is the this is mapped to that filtered precipitation collection, and then we will flatten it to be exported later. So here again so many things are going, just playing with the dates and just playing with the dates. And then same thing is happening with the land surface temperature. We are using this LSD start date and this request in date to be advanced every 8 days. Selection, some of the bands are down here, and then we are doing some use of quality pixels to mask the pixels that are not of that quality, and then we are mapping this function to that filtered collection, and then again some rescaling is to be done meaning multiplying up with some constant and subtracting it with some constant to convert it into the degree Celsius. And then also the average of the day and night temperature is being done here, and this will be returned as the new bands. Here we apply this function here. This function is applied here, and then here we do the list of dates again, finding the maximum date or the date that is the recent, and then this is advanced to every 7 day. Difference between the end dates, the start date is being done, and then the sequence is being created, and for each sequence the addition of some advancement is being done for the dates. And then here some calculation is being done. So it says the function to calculate the daily LSD by assigning 8-day composite summary to each day in the composite period. And then this is being done here for each day, and it's being returned with the new bands added and new properties added. And then here finally filtering of the original dates are being used, the start and end dates. And finally this is the main thing that is very important is this one here. The function here does the mean of these image bands, the day and night, and the average of the day and night. And this is the main thing, but everything that happened before was to get to this and this point. And then this is again flattened to export it as the CSV later. And here we're calculating the NDWI. For this we are again selecting some of the bands and renaming it, and same thing is being done for the other data set. And these two image collections are being joined with the left field and right field, meaning these need to have same properties. And then after that we are doing this QA bands are added to the collection, and here we see some masking being done with the quality pixels that were just added. And here some calculation is being done. This is the dot normalized difference, selecting the two bands for the calculation of NDWI. And again here some dates are being created, and then the dates from that dates the maximum date or the date that is the recent one is being done, and from that differences are difference between the two dates, end date and start date is being done. The sequence is created, and in that sequence addition of the days are continuously done. And then this function is being created here, and in this function filtering is being done, and from that filter the first image is selected, and this empty result, and it says they create empty results to fill in the dates when BIDF data does not exist. And this function creates those dates where the data doesn't exist, and the filter is being created for all the dates here. And then the main dates that we used earlier are is being filtered here again, and the filtering of the spectral indices is being done again here with the start and end dates. And then again, the main part here is this one, where the ee.reducer.mean is doing the mean of those bands, or the NDII. And finally, we flatten it to be exported as CSV. Again, these are some of the things that's just going on with dates on and on and on. We selected the bands, renamed it, selected the bands, renamed it, added 2 different image collections, used those image collection for the updating the mask, and then we calculate the spectral indices, and then we did this maximum date, that in date, or the latest date, and the subtraction between the two dates are done, and the sequence for that number of days are done again, and then we advanced with each one day, and then again we do this daily PIDF values, meaning the filtering is done and selecting the first image within those images, and then if something doesn't exist there, then the dates are just added, and then finally the main important one was this one here, where ee.reducer.mean is applied for the NDII, and we finally do this dot flatten to be exported as the CSV. And here now it gets more easier. Now we are adding the images as the layer. Here we are filtering it with some dates, and then we're selecting the first image and selecting the bands, and then here we are the color palettes, and all we are doing now is the addition of those images as the layer. And here is, it gets easier now. Everything is just is being added as the layer here. And here now we finally export those collections now, and here we see this naming system being done, some prefixes there, and some last dates, summary in dates. So these are just to just for the exporting of the final feature collection. So here we are using this export.table.drive, and we provide the collection, some descriptions are provided, and then some selections are being done. And these are just going to do this formatting or the renaming of the name. And this is what's being done here. And finally, in the last section, we import the processed data or already analyzed data, and we are just displaying it as the layer. And here some values are assigned for each of those gaps between the data. So it is from 1 to 5, just the categorical data, and then these are being added as the layer. And this ends my attempt to go through the course, and I think I have done it very poorly. I know it, because you know, these dates are making just confusion everywhere, and but these are again done to, you know, filter the dates accordingly. And I think this will be useful when we try to work with the dates, but we just do not use these dates like this. I think we just directly jump to the reducing of the images. So maybe this might be useful in particular cases where we require such analysis. But it happens when you try to do the mean of the images, we directly jump in doing that. However, there are so many things or so many bits we can learn from this chapter, and although this chapter is about the health applications, it is more about this getting these data from the Earth engine. So I hope this video was helpful at some extent, maybe. So I would say thank you for watching.